Liver is the major organ responsible for the metabolism of xenobiotics. Metabolism of xenobiotic has two phases, phase 1 reaction and phase 2 reaction. Phase 1 reaction, it is the alteration of a foreign molecule. Xenobiotic, it is a foreign molecule. So phase 1 reaction, it is the alteration of this foreign molecule to add a functional group which can be conjugated in phase 2. So the phase 1 reactions involve oxidation, reduction and hydrolysis. And the metabolites, it may be excreted without any further reaction, or it may enter into the phase 2 reaction. So in phase 1, the major reaction involved is hydroxylation. And this hydroxylation reaction, it is catalyzed by cytochrome P450 or monooxygenase. So here in phase 1 reaction, a group is added to the compound so that it becomes less toxic or water soluble. And the examples of oxidation include oxidation of alcohol, example the oxidation of methanol to formic acid. Here methanol, it is converted into a more toxic form, that is formic acid. This is known as N-toxification. Then other examples are oxidation of aldehyde. Benzaldehyde, it is oxidized to benzoic acid. Then the oxidation of amines, oxidation of aromatic hydrocarbon, oxidation of sulfur containing compound and oxidation of drugs. These are the examples for oxidation reaction. The major group of compounds which are reduced and detoxified by liver are nitro compounds. So these are reduced to their amines, and aldehydes or ketones, they are reduced to alcohol. Example for reduction reactions are picric acid converted to picramic acid and para-nitrophenol to para-aminophenol. Then the third one coming under phase 1 reaction is hydrolysis. So in hydrolysis, bigger molecules, they are converted into two smaller compounds. So hydrolysis, it is a chemical reaction in which the addition of water molecule split the toxicant into two fragments or two smaller molecules. So hydroxyl group, it is incorporated into one fragment, and the hydrogen atom, it is incorporated into other. Example, aspirin, which is the most usually used drug in clinical practice. This aspirin, it is converted to salicylate and acetic acid. Phase 2 reaction, it mainly involves the conjugation reaction. In most of the cases, the conjugation will make the compound non-toxic and easily excretable. The conjugating agents used are glucuronic acid, sulfate, cysteine, acetic acid, glycine and glutamine. In many cases, phase 1 reaction products will be the substrate for phase 2 reaction. And the major enzymes involved in these cases are uridine diphosphate, glucuronyl transferase, glutathione transferase and sulfotransferase. So conjugation with a conjugating agent convert lipophilic compound to hydrophilic compound so that it can be easily excreted from the body. So this phase 2 reactions include sulfation, acetylation, methylation, conjugation with glucuronic acid, glutathione. Glucuronide conjugation is the most common phase 2 reaction, and bilirubin is a good example for compound conjugated and excreted as glucuronide. This glucuronide, it can conjugate with hydroxyl, both phenolic and alcoholic compounds. Next is conjugation with sulfate. Sulfation, it decreases the toxicity of xenobiotics. So the highly polar sulfate conjugate, they are readily excreted through urine. Here, phosphoadenosine phosphosulfate act as the sulfur donor. So this sulfotransferase, it can transfer sulfate from phosphoadenosine phosphosulfate to phenol or indole. Then steroids and indole compounds, they are also excreted as their sulfates. Cysteine, it is derived from glutathione. It is also an active conjugating agent. Then conjugation with acetic acid is taking place with drugs like sulfanilamide. Then a few xenobiotics, they are subjected to methylation for their excretion. Here S-adenosyl methionine act as the methyl donor. Give two examples of detoxification by conjugation. We have already discussed conjugation comes in phase 2 reaction. So examples, bilirubin, it is conjugated with glucuronic acid to form bilirubin glucuronide. Then phenol to phenyl sulfate. These are examples for detoxification by conjugation. Cytochrome P450, it is heme containing enzyme which is located in the endoplasmic reticulum of liver. NADPH is the coenzyme required, and this is an inducible enzyme. In phase 1, as we already discussed, in phase 1 the major reaction involved is hydroxylation. This hydroxylation reactions, it is catalyzed by monooxygenase or cytochrome P450. There are about 100 different cytochrome P450 isoenzyme. So this monooxygenase, it is also called as mixed function oxidases. Then cytochrome P450 enzyme, they hydroxylate many physiological compounds such as steroids, polyunsaturated fatty acid, drugs, carcinogens, etc. We have already discussed the coenzyme required is NADPH. In this mitochondrial cytochrome P450 enzyme, it will catalyze steroid hydroxylation. In addition to hydroxylation, these enzymes can catalyze a wide range of reactions like deamination, dehalogenation, desulfuration and reduction. How benzoic acid and sulfanilamide are detoxified in human body? How is benzoic acid detoxified? It is conjugated with glycine to form hippuric acid. Then it is excreted through urine. And sulfanilamide, it is conjugated with acetic acid. Then one example each of detoxification by oxidation and conjugation. For conjugation, the example is benzoic acid is conjugated with glycine to form hippuric acid. Then oxidation, toluene, it is hydroxylated to benzyl alcohol. Then mention two example for detoxification by reduction. Nitrobenzene to aniline, picric acid to picramic acid, then para-nitrophenol to para-aminophenol. All these are examples for detoxification by reduction.